Today we are diving into AWS Transit Gateway, a powerful and scalable virtual routing service that centralizes and simplifies your cloud network architecture. If you are managing multiple VPCs, on-premises networks, or need multi-account connectivity, this service will be essential for your toolkit. Let's break down how AWS Transit Gateway works, its advanced features, and how it can streamline your cloud infrastructure. So, what exactly is AWS Transit Gateway? At its core, it's a hub and spoke model for your cloud networks. This means instead of setting up multiple point to point connections between VPCs or VPNs, you create a central hub, Transit Gateway, where each network connects only once. This dramatically simplifies network management, especially when you are dealing with many VPCs, on-premises connections, or even direct connections using AWS Direct Connect. Traditionally, with VPC peering, each VPC required a unique connection to every other VPC it is needed to communicate with. This often led to complex mesh architectures. AWS Transit Gateway changes that by allowing a VPC to VPC connection through the central transit gateway. No more spaghetti networks, just a clean, scalable hub. One big advantage of Transit Gateway is its scalability. It's designed for regional use, but it doesn't stop there. You can actually interconnect transit gateways between AWS regions. This means if you have a global presence, you can create a cohesive worldwide network architecture that connects your VPCs, on-premises data centers, and remote sites seamlessly across regions. This feature becomes critical when you are scaling globally, but it still wants the simplicity of managing everything through a single transit gateway. Let's talk about routing. Transit Gateway supports both dynamic and static routing. For dynamic routing, it uses Border Gateway Protocol or BGP. BGP enables the transit gateway to dynamically learn new routes as you add or remove networks. This is particularly useful if you are running dynamic environments where your VPCs, on-prem, or VPN connections are frequently changing. If you prefer more control, you can always configure static routes. This is where you set up manual routing rules to dictate the flow of traffic, making sure your network behaves exactly as you want it to. One of the key aspects of Transit Gateway is that it supports both IPv4 and IPv6 using multi-protocol BGP or MP-BGP. Even if you are routing purely IPv6 traffic, IP4 is still used for the BGP peering connection. Additionally, if your network architecture requires flexibility, Transit Gateway also supports generic routing encapsulation or GRE for tunneling. This adds another layer of customization for connecting disparate networks or supporting legacy systems that require generic routing encapsulation. Another advanced feature is native multicast support. This is crucial for scenarios where you are distributing data to multiple recipients simultaneously, like streaming media, broadcasting, or software updates. However, there are some limitations. Multicast is supported within and across VPCs, but it doesn't extend over direct connect links. So if you are planning to use multicast across your on-premises connections, keep that in mind. Now let's touch on network segmentation. AWS Transit Gateway allows you to create multiple virtual router forwarding or VRF tables. Each virtual router forwarding is essentially a separate routing instance that you can associate with different VPCs, VPNs, or even on-premises connections. This gives you complete control to create isolated environments within the same AWS account. Whether you are managing different teams, departments, or applications, you can ensure traffic stays segmented and doesn't bleed between environments. From a security standpoint, AWS Transit Gateway integrates seamlessly with AWS Identity and Access Management (IAM). This allows you to control access, define policies on who can create, modify, or delete resources, and ensure that only authorized users manage your networking infrastructure. Transit Gateway also works hand in hand with AWS Network Manager. This integration provides a centralized view of your global network, not only within AWS but also including on-premises resources. You will get access to detailed metrics which are invaluable for monitoring and troubleshooting your network. AWS Transit Gateway also supports integration with major SD-WAN vendors. This is particularly useful if your organization already has an SD-WAN deployment and wants to extend that into AWS Cloud. By leveraging pre-configured VPNs, you can easily connect remote sites to your cloud architecture without requiring a complete redesign of your existing infrastructure. While Transit Gateway simplifies cloud networking, there are a few limitations to be aware of. One is a lack of support for transitive routing across peering connections between different transit gateways. If you pair two transit gateways, you will have to manually configure static routes, as route propagation won't occur automatically. This can add a layer of complexity when you're managing larger multi-region deployments. Each transit gateway also comes with a default route table, but it's a good practice to create multiple route tables. This gives you greater control over how traffic is routed between your VPCs, VPNs, direct connect gateways, and other networks. AWS Transit Gateway is a critical tool for anyone managing complex, large-scale cloud architectures. By centralizing network management, simplifying routing, and supporting advanced features like multicast and VRF tables, it helps organizations stay agile and scalable in the cloud. If you are looking to simplify your cloud network architecture, scale globally, and improve security and control, AWS Transit Gateway is definitely worth considering. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more deep dives into cloud solutions and architectures. See you in the next video.